All right, let's get started. So today, we're here to talk about, how to lower your observability cost with an open stack. And we're going to go through a little bit about where is this cost increase coming from? Where's the money going? And then how you can really tackle this issue with open source and some interesting technologies. Here's the agenda. We also have a demo at the end to show how and provide some information on how you can replicate the setup and the stack if you're so interested to try it yourself. Before we dive into the meat of this conversation, I just want to give a brief introduction to VeloDB and Apache Doors. So VeloDB, which is the company I'm part of, I'm a product manager at VeloDB, is a real-time analytical and search database. So really specialized in providing real-time capabilities for analytic as well as search. It is a open source, it is backed by an open source project called Apache Doors, which came originally out of Baidu to solve some of their real-time analytical needs for their platform, and has since gained a lot of traction. And the PMC chair, as well as 26 committers, are part of VeloDB, and we're headquartered in the US with operations in Singapore. For Apache Doors, this is a top-level Apache project. We have more than 14K GitHub stars, almost 15K, and a lot of enterprise users across the world leverages us for their business, and we have a rich community of 700 plus contributors. And then you can see some of the logos on the right side about companies who actually leverages the technology for their enterprises. This includes both customers who leverages the open source version of the product, as well as those who leverage commercial version of the product through VeloDB and associated companies. If you're wondering what are all of the different things you can use VeloDB for, beyond observability, you can also leverage it for traditional data warehousing, online analytical processing workloads, for customer-facing analytics, such as web analytics. Really combining the ability to search and join data is really, really helpful. And also recently with our latest release, knowledge stores for generative AI, as we're now supporting vector indexes on top of the full text index and SQL filters. So you can really do some cool things on retrieval augmented generations in the Gen AI space. And you can see that we integrate with a rich ecosystem of related products in data management with transactional databases, handling operations, streaming sources, and data lakes where a lot of your analytical data may be stored, as well as transformation tools and visualization tools. But we really deliver all of this real time, and that means high data freshness, low latency queries, and very fast and efficient writing the data to the database so that it's available. But for today, we're going to focus in on the observability use case with Apache Doors and VeloDB, and primarily tackling how things get so expensive and what we can do about it. So to kind of really understand why things get so expensive, we really want to look back in history to understand where is all of this data that's causing the cost to go up coming from. And it really is a natural revolution of computing as we go from a monolith systems where the goal is really just to make sure is the system on, is the system functioning, to a distributed world of microservices and dependencies. With these microservices and dependencies, root cause analysis gets more difficult. Understanding the series of events gets more difficult. And that's why for observability today, we primarily look at logging events in terms of the series of things that happened, traces so that we can understand the dependencies, the upstream, and then critical metrics so that we can build alertings to understand anomalies. So those three pieces of data that are really heavily being used in observability is really trying to describe this distributed system. And this problem is actually getting worse with agentic AIs because as you're adding more components, more dependencies, more metrics, logs, and events that you have to measure, the problems that are introduced during the microservice days are just getting amplified. You have more text data, more events that you have to ingest, and more metrics to look at. So, if things are going up, where is this money going? Well, if we look at some of the practitioners on Reddit, we can see that a lot of this money is going to vendors who provides a complete solution. I'm sure many knows that many have complained about vendor bills, particularly in this case, Datadog. But if we look closely, we can also kind of understand as part of this, what else are they spending on? Well, they're spending a lot on ingestion. They're spending a lot on the storage of some of this data. And one way people have decided to try to reduce costs is to sample. So I'm going to store less data. I'm going to ingest fewer events. But that trade-off is that you may have a loss in the ability to diagnose, to be able to understand uh, issues faster. And what if there's a better way of doing this? Well, some members are fed up with paying vendors and really dealing with some of this trade-off, and therefore decided to build based on open source components, leveraging open source softwares that do not have a predatory way of metric and billing, so that they can really measure, store, and use all of the data that's being generated, so that they can really advance their business. And the stack that we're going to talk about today, based on that are open source, is the OpenTelemetry, Doors, and Grafana stack. OpenTelemetry has been a really good piece of technology that gained a lot of traction as a collector. In my previous roles managing different SaaS products, I also used OpenTelemetry as a collector. Grafana has gained a lot of traction as a visualization, so allowing people to really understand and visualize traces, search logs, and then understanding metrics by creating a center set of dashboards for alerting. But all of this still doesn't address some of the costs and challenges that are coming out of ingestion and storage. You still want to keep all of this data, and you still want to make sure that you have an efficient way of getting the information into an environment that you can run these analysis on. And that's where Doors comes into play, where it can offer that efficient ingest and storage, as well as offering good compatibilities with these other tools so that it is not so hard to put together a solution that you can run on your own. So let's talk about some of these integrations to start off with. One of the things to get data into a system is really dealing with exporting a lot of the data where it's being collected. And to make this easier, we have built the Doors exporter for OTel so that you only have to really kind of understand the data that you wanted to move and set up the configurations, and we'll handle a lot of the schema mappings and so forth, so that it is more seamless for you to get data into VeloDB or Doors. At the same time, we also added integrations with Grafana in the form of a plugin so that we can offer better experiences in terms of connectivities. It is based off the MySQL protocol, so hopefully it's familiar. We also provide dual syntax, so you can use SQLs to query your logs or Lucene searches, full text searches. And this can be done through the Grafana interface or even in the VeloDB console itself. We also have interactive discovery, very much like Kibana, so that you can search, filter, and analyze log traces and metrics, as well as getting all of the context around those information. And hopefully this is still very user-friendly with the nice UI for you to kind of configure the views that's most interesting to you. And I'm sure many of those who are already using Grafana or OTel already appreciate some of the capabilities and features here. And we're basically providing a nice seamless integration to keep what you like while making sure that you're optimizing the components that's causing pain. So we talked about that integration, so this stack, but when it comes to storage costs, this is one of the limiting factors where previously the only lever is to store less of that data, shuffling it to different tiers. And one of the paradigm today is that many stores this data in OpenSearch or Elasticsearch. This is somewhat problematic because when you're leveraging these types of storages, there are storage duplications. Oftentimes, because you want to be able to have efficient ingest, since you need to use this data very quickly while it's fresh, you're ingesting this in a row format. And then when you're running analytics, because you also want to be able to relate across and you want good performance querying it, you want this to be in columnar. So these two things are commonly at odds with each other because you want data freshness and you want good performance. So many system stores two copies of the data, a row format and a columnar format. And to make sure that things are actually can be searched correctly, an inverted index is applied across. In the case of Apache Doris and VeloDB, we actually only store one copy of the data in columnar storage. And we have a special technique to get data into storage faster through something called a stream load. So we use micro batches to load the data in. In the next slide, I'm going to talk a little bit more about the additional optimizations on ingestion to further enhance the efficiency of the system. So that's number one. We are storing just few less duplicates. Number two is that we're using ZSCD compression, a balance of retrieval and the storage volume, unlike some other ones, compression types, which also further reduces the storage volume down. And we also understand that storages are not created equal. There are different types of storages. Some are great for cold storage, less expensive, but it takes a little bit more time to retrieve. Other things like SSDs could be used for hot storage, which is uh, data that you want to retrieve immediately. So we also have the ability to offer different tiers of storage because Apache Doris and VeloDB has a storage engine, so we can really think about how to optimize tierings. Whereas you really can archive the data that you may not query the most often in that object storage tier at a very low cost, and then only cache the hot storage or the most recent data where you may be where we may be using it for root cause analysis and troubleshooting. Overall, we have seen up to 10x in storage cost reductions in the most extreme cases, and then in the most, I would say, less optimal cases, at least a 2x reduction, because that could be a particular customer needs more of their data in hot storage, therefore unable to take as much advantage of the tiering. But storage is really only one side of the issue, and it really only applies to organization of a sufficient size. For smaller or medium-sized organizations, the storage cost may not be of a concern yet. Although with agents, that could potentially become a concern for more as we go forward. However, everyone deals with ingestion costs because under the cover, all of these ingestion tasks relies on CPU cycles. Because of that, this is one factor that you cannot escape. And when it comes to efficient ingest, there's actually a lot of architecture and optimizations that's built core into the engine, such as fully vectorized engines, MPP architectures, as single executions. So all of these things are really about making efficient use of the CPU, and by nature, no matter really what type of data that Doors ingests, it does that. But for observability, we actually have some additional techniques, in which case we leverage something called the group commit. Because one of the things that also cause a lot of ingestion is the cycle of going back and forth on the network. If you have a lot of these micro batches coming in, every cycle consumes compute. But if you can group some of these commits via time, you can minimize the cycle of compute going back and forth between the sources and where it needs to be written, therefore reducing the actual compute usage. And hence, with the time series compression, we can actually further reduce the CPU cycles used for ingestion while maintaining a relatively high throughput. In this case, we can guarantee about a 10 gigabyte per second throughput with a 1 second freshness using group commit. So it doesn't actually impact performances in a meaningful way. But, you know, talking about it is not as strong as showing. So here I want to show some benchmarks of the different log, trace, and metrics, the type of data that we're ingesting, showing how fast we can ingest this data, as well as the relative storage volumes that are used to store these metrics. So on the graph on the left, we're talking about log and trace ingestion and storage. So mainly log ingestion. And compare against some of the solutions out there, such as Elasticsearch, we're orders of magnitudes faster in terms of the speeds that we're able to ingest. And if we look at storage volume for that, it's actually a fraction of the storage volume. And none of this really impacts query performance because we can still provide excellent performance compared to some of the other options out there. When it comes to metric, the story is very similar. In this case, we can absolutely write metrics very quickly because this is born from traditional relational stores. So writing in a tabular, straight metrics, not an issue. And storage volume is not an issue. And of course, retrieval is not an issue. And in fact, if you actually want to join this metric against other pieces of information to enrich uh, the data sets that you're looking at, we can do so as well with excellent aggregation performance so that you don't actually have to look at denormalized data only. But we also want but cost isn't the only reason why our customers pick VeloDB and Doors for observability. There are other reasons that customers pick it, and these are some of the ones listed on this page. These are direct quotes from our customers, and they say some interesting things. So there are some that must look familiar, such as real-time ingest and querying. We can ingest massive amounts of data in columnar storages and make it available to query and analysis in seconds. So this is what we talked about with the ingestion performance as well as the query performance. We also offer multiple interfaces, such as text search and SQL. So there are many folks that are familiar with these experiences and can get started very quickly. We can handle aggregations as well as pre-aggregations. This is that join capabilities that I talked about it, as well as cost-effective scaling. So this doesn't just apply to a small amount of data, whether you have 10 terabytes of data, 100 terabyte, or 10 petabytes of data, the promise is the same. And finally, something that we often take for granted is the columnar storage with these fast scans, so that as you widen your analysis of your data, performance is able to keep up. And this is also important because you may want to make sure that your analysis run to completion. And if you have reliability issues or times where you're running the issues with scales, it adds additional burden to operations. You may have to do special tuning, you may have to do special configurations, provisionings, all sorts of different things. And having something that's able to scale in a robust manner with performance mitigates a lot of those issues. And if you're wondering who are our customers, or if you like to read about their stories about how they're able to handle observability at scale, here's a few examples on the page with some of our most well-known customers. And if you would like to read about their stories in detail, this is the link to our blogs page where you can search for these stories and take a look at them uh, whenever you have some time. So the next step is that we're going to go through a demo. So I'm going to showcase a live environment with OpenTelemetry integrated with VeloDB, the commercial versions of Apache Doors, as well as Grafana. But if you want to try this demo yourself, here is the GitHub link where you can get the repo and set up the stack on your own. So with that, I'm going to stop sharing to pull up the demo environment, right? Hopefully everybody can see. So thanks to our incredible solution architects, we actually have a nice visual to visualize all of the different components in this open stack that we're showcasing today. So the first thing is we need something to observe. In this case, we're using a standard OTel demo source. So this is simply just a product page where it's a dummy app with a front end, back end that we can observe into. Uh, Looks like an e-commerce site. And you can kind of see the different components. So it's a TypeScript front end, Java and C++ back end, and it uses a transactional data store for the transactions that it's processing for that application. And I've set up OpenTelemetry as the collector to collect log, trace, and metrics. And then all of this is ingested into VeloDB. So the first thing I'm going to do is to showcase this information inside VeloDB and to also provide a view of what VeloDB looks like on SaaS. So immediately after I log in, I have an active running warehouse that you can see. This is a US-based warehouse running on the latest tech preview version. So if you haven't seen the tech preview version, check it out. It has a lot of cool features that came out in December. And we're going to go and take a look at this demo cluster, which is running the warehouse. So we're going to explore in the query editor. And we'll see that there's a whole set of schema. In today's case, we're really interested in the demo observability, and there's a set of OpenTelemetry tables that we can look at. So here you can select from the demo, using the demo cluster, you can query it by SQL right here. So we have demo observability. And if I want to just do a quick select query on the OTel logs, I can do so. But I think metrics might be a little bit more interesting. So let's take a look at metrics some. So I'm just going to quickly insert the name and do a select star statement. Maybe a little bit 100. That's fine. Or, oops. Oh, there we go. You can see this is the metrics table, and you can use SQL to play with the data. But also at the same time, if you wanted to actually search with full text search, we actually provides that experience as well inside our console. So we can select the demo cluster, we can select the observability, OTel logs table, and now I'm seeing all of the logs, but let's say I'm only interested in logs that have the app WebKit. So I can search for Apple WebKit. And you can see Apple WebKit, it returns. Again, there's a lot of other cool things, such as session management, query audits, workload groups, really to manage things within VeloDB. But oftentimes, this isn't where your SREs or your operational folks are working in. They're probably working something like Grafana. And in this case, we have Grafana also integrated, where we can actually better visualize some of the traces in addition to logs and metrics. And we're going to go through some of these things right now. So first thing first, we'll start off with a dashboard. So I'm just going to click on the dashboard and we can click at the metrics dashboard. And this dashboard essentially shows the metrics. This is a metric on requests per second. It's pretty stable, and you can configure it as based on the metrics that you care about. We can look at traces next. So this is a way for you to really search through the traces, and you can click on each of this trace panel to understand exactly the time spent on particular events, to understand where latencies, drop-offs can happen. And further, there's also a more deep dive trace analysis where you can really get into the nitty-gritties of the events and understand what may be happening inside for a root cause analysis. And all of this is integrated with the Grafana experience, so you can really explore, discover, filter, and create parameters that meets your need. So pretty straightforward to set up, very easy to start exploring all of the different observability data that you care about. So let's get back to our presentation. Really, so I wanted just to kind of leave the rest of the time that we have for questions. But if you do wanted to try yourself, feel free to sign up for a free account. Use the GitHub repo to set up the OpenTelemetry and Grafana components. And if you're interested in some of the stories that we have to share, feel free to look at our blogs. We also have documentations both in the open source and the commercial version, as well as ebooks and slides if you want to explore some of the other use cases associated with Apache Doors.